of the Agile Alliance, and we have been meeting here over the weekend. The Alliance itself is a global organization. One of the things that we are trying to do is figure out what our mission, or our vision statement, I always get those two confused, I'm sorry, Diane. Our vision statement really is to help make the software industry more humane, productive, and sustainable. And that sounds great, but then we have to figure out, well, what does that really mean? What kinds of things should we as the Alliance be doing to support these activities? And that's a lot of what we were talking about this weekend. Obviously, we have the large North American conference that we put on once a year, which is the primary activity that the Alliance has undertaken over the last several years. However, we have recently begun discussions with a group in Brazil to form a partnership with the group that puts on the Agile Brazil conference to start to extend our reach internationally. We've been partnering also with the group in India that puts on the Agile India conference. So we're looking at how can we start to spread this message more widely across the software industry globally. We also, one of the things as an alliance, we try to make opportunities available for people who are members of the Alliance to participate in this mission of advancing the state of the art and the state of the practice of Agile software development. We have a mechanism for programs where ideas that come from the community, we have a mechanism that can help fund some of those things. But we spent the weekend really trying to think about what are the ways that we can engage more with our membership, advance our vision statement for changing the way software is developed. We did some pretty wild and wacky brainstorming about maybe we ought to have an outpost on Mars and a few things like that. But the idea really is also that we want to think about what are very different ways that the Alliance can begin to engage more with its membership. So if you have ideas for us, we're always happy to hear them. I can be reached through chair@agilealliance.org. We have most of the board here, not all of them. A couple of them had to go back. Unfortunately, our managing director, who had intended to be here and probably give you, this, he would be giving you this rah-rah speech rather than me. He had to go home early. But we are interested in hearing from people who are passionate about Agile software development. And let's see. I also want to introduce, he's not speaking today, but Declan. Declan, would you stand up? He's also on the board of directors. He's our Canadian member.
One of the two Canadians.
One of two Canadians. Ironically, Paul Culling, who is also on the board, was going to host us here until his brother-in-law decided that this weekend he was going to get married. And his wife was not really excited at the prospect of him staying here for a board meeting rather than attending her brother's wedding. So that's why he's not here today. Otherwise, he would be here with us as well. So I want to thank you again for showing up. As Philippe said, hopefully we can have an interesting discussion of things that are not quite as mainstream as Agile 101. So Diane.
That's why we're having another software project. Actually, PK's really helped me out. She took over half my project.
So when did they start their first one? I think it starts at 9:30.
The more demanding, right?
They said 8:30 is orientation and
Pardon me? No, PK is that little college.
8:30 was introduction. I thought, okay, that's
Yeah, so he's also helping. And he's both our bosses. Not him, no. The director that the firm works with. He's really passionate about it. Yeah, he's really smart. Not but he's very passionate, very opinionated. I hear he doesn't know. He doesn't know.
say session 1, 9:30. Introduction and welcome 8:30 to 9:30.
A lot of experience with podcasts.
Session 1, 9:30.
So Amos told me about him as well.
Oh, yeah.
Well, you know our whole company, isn't it?
Nah, well, I know her really well. Well, she's Iranian, he's Iranian as well. So it's,
Yeah.
no, I haven't seen you.
Okay. I forgot my little bell. Next presenter is Rebecca Parsons from ThoughtWorks. She's been already at Agile Vancouver in one conference in the early days when we were still, looking in the dark what such Agile stuff is about. She's going to speak about a topic that's much dearer to my heart because I'm a software architect. I just fell into Agile stuff by accident. Which is this ugly thing called software architecture. Oh, boo, big upfront design, people would sort of say. We don't do that, we're agile, We're going to just furiously refactor, and the architecture will gradually emerge out of the tar pit. Anyhow, I won't steal too much of your talk, Rebecca Parsons.
Okay, thank you, Philippe. So I actually spend a lot of time working with architecture groups, and very often I'm asked, how do I make architects and developers get along? Because they often seem to be working at cross purposes, where in fact a big part of the problem is developers don't understand what it is that an architect's worried about, and architects don't really see what's going on in the development organization, so they don't see what's going on. But what this talk is really about is trying to look at, if we really believe in this notion of evolutionary architecture, how do we know how to do it, and how does it actually play out in the wild? Thank you, Philippe. Okay, so what am I going to talk about? First, why should we even care about architecture? Are there things that really matter? And then I want to talk a little bit about, I want to distinguish design and architecture, evolutionary architecture, emergent design, because these are terms that get tossed around a lot, and it is a continuum. Then I want to go through some of these principles, some of the things that help us describe what does evolutionary architecture really mean, then a few specific techniques, and talk a little bit about how that shows evolutionary architectures in action, as you will. And then I want to kind of bring it back to, okay, so how do I actually really make this work? So I want to start with the why should I care? Why should you all be at all interested? Now, many times when we think about architecture, there is, again, a wide spectrum. If you are working by yourself, you still have to think about all the architectural questions, but you can manage those questions and manage those issues in a very different way than someone who's sitting in an enterprise that has 50,000 developers scattered all across the world. Although the questions, the concepts, the issues that you're dealing with are the same, whether it's you writing a program all by yourself or 1,000 people trying to write it, how you handle those problems are different. And what you can do is quite different. So the first reason why we should care about things like evolutionary architecture is the pace of expectations of change are increasing. When Twitter comes out with some new customer engagement mechanism, all of a sudden everybody wants to use it. It used to be that expectations did not travel through a user community as quickly as they do now. But expectations are changing very rapidly. In addition, business model lifetimes are shrinking. It used to be that if you found this new business model, how you're going to make money, how your organization is going to make money, you could expect that to last for 5 years, 15 years, 30 years. Now you're lucky if that fundamental business model is still around in 6 or 12 or 18 months. And so you have to be able to change your systems much more rapidly because your ability to make money from something, that time frame is shrinking. And it's harder to predict the future. Now, I don't think anybody's ever been particularly reliable about predicting the future, but if you roll back to the very early days of IT, expectations were very low. We had all of these basic manual processes, and it wasn't really that hard to figure out, well, first you're going to do the basics of maybe payroll or accounting, and then, oh, well, maybe we'll advance to automating some other manual process. So it was a bit easier to predict what might come next. With the pace of technological change as well as expectations, the environment around us, it is even harder now than it ever was to predict the future. And in many cases, you have a very narrow window of opportunity to exploit something, where you're the first to the market. And there are many of these graphs that show, if you can handle the spike, when something goes viral, you've got maybe a couple of days where you can make a whole lot of money, and then it just tanks. If you miss that window, you've missed 90+%, if not more, of your potential revenue. So these are all the reasons why you need to be able to change as quickly as possible, and that's what evolutionary architecture is all about. You want to be in a position where you can evolve your systems. Now, what do I mean by architecture? And how am I distinguishing design and architecture? So first, I want to distinguish between two terms, evolutionary and emergent. This is a debate that Neil Ford and I get into a lot, and I think he's finally come around to my way of using these particular words. To me, when we talk about emergence, it is a very unstructured process. There isn't really a guiding force. You look at what's there. Okay, well, I'm going to arrange things this way. And that organization is emerging based on your interaction with just what's happening. There's very little guidance except perhaps this vague sense of cleanliness or simplicity or something like that. When we think about evolution, though, I key on what I want to refer to as the fitness function. I am setting out a specific requirement for what I think this ought to look like. Some of them are going to be notions like, does it work? Is it simple? But some of them are going to be much more problem specific. One of the examples I often use, and these two systems came from the same client. One was a sandwich ordering system. There were maybe 500 people in the building. And every morning between about 8 and 10:30, maybe a few hundred of those people would get on the sandwich ordering system. If it wasn't up, no one was going to starve. This is central London. There were stores everywhere. Not a massive load. If it took you 5 seconds or 10 seconds or even, heaven forbid, 30 seconds to order your sandwich, that wasn't going to be a big deal. You wouldn't care about that system in the same way you'd care about a high transaction volume system. The world is not going to end if one day the sandwich ordering system wasn't working. So the architectural requirements of the sandwich ordering system are trivial. And in fact, it is wasteful to invest a whole lot of time making it bulletproof. So what if it crashes? Somebody might have to actually walk down the stairs and walk down the street and buy their own sandwich. This same client also had a trading system. Now everybody thinks trading, okay, high volume, high transaction volume. This trading system, in their wildest dreams, maybe would have 100 transactions a day, globally. But each transaction was multiple billions of dollars. They didn't care about throughput. They didn't care about speed. They cared about there was absolutely, positively no way any message was ever going to get lost. Because billions and hundreds of billions of dollars on one transaction, that's what they cared about. So their architectural fitness function looked very different than what it would look like for some other kind of system, and even some other kind of trading system. So in an evolutionary sense, what I'm doing is I'm giving you a fitness function. I'm telling you this is what good looks like. And that's how you start to assess how your architecture is evolving. Is it becoming fitter relative to my fitness function. And that's how I determine it. So emergent, you look at what's there and you make do. In evolution, you have a target. And that target is your fitness function. And everything that you're doing is moving you towards that target. Second, design versus architecture. Again, this is a continuum. When we talk about design, I'm generally talking about specific code issues. And when I'm talking about architecture, I'm talking at a larger scale. How am I chunking things up? How do those different chunks communicate with each other? How am I deciding what my infrastructure is like? All of those structural issues. Now, obviously, at some point, when you're writing object-oriented code, you're deciding, is this one class or two? Isn't that a structural question? Yes, there is a gray area here. And at some point, you might, in fact, from an architectural sense, go down to something that used to be called components, business components. And this used to be a very important architectural function, was how do I define my business components? I'm not going to debate that particular continuum, but that's kind of what you see in the middle is, where do I draw the line between what is an architectural concern in terms of these, what is the chunk of functionality, and what is a design concern, which is a lot of what refactoring and emergent design is about. So when we think about comparing evolutionary architecture and emergent design, these two things do work together. But emergent design is really focused, almost if you will, on the code looking in. And more of the architectural concerns are almost looking at it from the systems level. So that's the distinction between design. So I'm not going to be talking about specific refactoring techniques. I might be talking about what you might want to achieve through a refactoring. So what are some principles? The first principle, I'm going to list them first and then go into more detail. Last responsible moment. I actually prefer to call this latest, but the established terminology is last, so we'll stick with that. It has to do with when we make decisions. The second is, how are you going to think about the code that you're working with? And you want to actually have an explicit goal of evolvability. And we'll talk about how you achieve this. So this is both from your architecture and how you design and develop your code. There's something called Postel's Law, which helps guide us in some of these architectural decisions that we need to make. It's also important to think about this from the perspective of testability. Everybody thinks ThoughtWorks is test-obsessed, and we are, so every talk has to at least talk about testing. But in fact, one of the things that we've found is that if you think about the testability of a system, you end up with a system that actually has a lot of different properties. And finally, there's something about Conway's Law, which is going to help us think about what does our organization look like, and what implications does that have for architecture. So these are the principles that I'm going to discuss. Let's start with the last responsible moment. And everybody hears this. Okay, we're going to delay a decision as long as possible, but no longer. Seems to make sense. You want to make sure that you're making decisions at this latest responsible moment, last responsible moment. And why would you do this? Well, obviously, the longer you wait, the more you know. If I make a decision in January about what I'm going to be doing in June, I don't know what things are going to be like in June. I don't know what the economy is going to be like. I may not have a job in June. We scheduled one of the Agile Alliance conferences a few years ago in Nashville, very early on, and the hotel flooded. And so we had to move the conference. We had no idea. Okay? So clearly it maximizes the amount of information you have to make the decision. And generally speaking, knowing more allows you to make a better decision. But it also will minimize the technical debt that you incur from complexity. Now, normally when we think about technical debt, we think about it in terms of, oh, I hacked some piece of code together so that I could get something out the door, and I know I'm going to have to go back and fix it. And so that's normally how we think about technical debt. But if you think about technical debt in a more general way, where you say, okay, actually what I'm worried about here is the drag, that this debt is a drag on my process. It's a drag on my productivity. Then there's another source of technical debt, and that comes from using a tool that's heavier than you need or that's inappropriate to what you need. Now, one of the examples that we use, very often people say, well, eventually I'm going to need some kind of message queue. And so they go out and they do this search about all what kind of message queues are out there. And you might end up with this heavier weight message queue, and you think maybe you'll need persistence of messages, or maybe you'll need guaranteed ordering, or you don't really know, but it would make sense that you might need these things. And so you end up with this message queue at the beginning of your development. And you're using this when you actually don't know whether in fact you need to worry about persistence or not. Maybe you could have used something much simpler than an actual separate message queue. Maybe you do need it, maybe you don't. Every single piece of development you do with that tool, before you know you need it, is a drag on your development productivity. So if you wait until you really understand what your requirements are for that message queue, all of that other development has been done more quickly. You have not incurred the drag that you would have incurred if you had picked that tool too early. Now, very often when I talk about this, the first thing that people say is, how do I know what the last responsible moment is? Why isn't the last responsible moment, I'm going to lock down all of my architectural parameters so everybody knows how to work? Why isn't that the last responsible moment? How do I know what I can afford to wait? Well, I go back to the architectural fitness function. If this decision influences one of your primary drivers, then chances are that's going to be something that's quite fundamental to your architecture. If I really do need to worry about massive throughput, then anything that addresses my ability to pump computation through is going to influence many aspects of the system that I end up with. So I want to do that earlier because it's going to influence so many of these other decisions. If I don't deal with those issues up front or early, then I'm going to have a whole lot of change to make. In my sandwich ordering system, I didn't even have to think about, okay, do I need an Oracle database and all of these different things. I mean, it just, those things didn't matter. It probably mattered more how grumpy people were using the interface. And most of the architectural questions really didn't matter. So you prioritize your decisions. You decide what is the last responsible moment for these individual systems based on, for that system, what matters. What are the things that are going to influence that development? What are the decisions that are going to be the hardest to meet? What are the criteria that are going to be the most challenging or the most important? So that's how you decide. And so there's going to be a whole lot of things that you don't worry about for a while, and you keep an eye on those decisions until you get to the point, okay, now I'm at a fork in the road. I've got to make this decision because if I go this way, it's going to influence things and that, okay? So this isn't just okay, well, the last responsible moment for this will be Tuesday and next month for that other thing. It's not a random process. You have to know what's important to you, though, to be able to work that. And finally, this is evolutionary. It's not emergent, and it's also not based on guesswork. One of the things that I find frustrating when I talk to so many architecture groups is these poor architects are put into a situation where they have to reliably predict the future. And I'm no good at that. And they generally aren't either. One of the workshops that I did here in Vancouver, there were about roughly 50 architects in the room. And I asked the question, how many of them thought they understood what success meant in their job? And most of them put their hand up. I asked how many of them felt that they were achieving those objectives and were successful in their job. 3 put their hand up. Now, these are people who were highly rated enough by their organizations to be sent to an international conference. When your job is based on predicting the future, it's very difficult to feel successful because you're not going to do a very good job at it. So what we're trying to do here is provide a basis where you don't have to guess. What you do instead is you try to set up a situation where the consequences of making the wrong decision are smaller. That's what we mean by evolutionary architecture, and this is why we say you need to think about evolvability as a fundamental characteristic of your system. Now, for the sandwich ordering system, doesn't really matter. If everything fundamentally changes, I'll rewrite it. It's not that big. It doesn't matter if it takes a little bit longer, okay? But you want to think about evolvability as a fundamental component of your system. How do I get evolvability? The first thing you need to think about, what is a sensible breakdown? How do you chunk different pieces of your functionality together? What are the sensible things that are together or separate? Because if you've got things too tightly coupled, if you've got things that are inappropriately combined, it's going to be harder to split them apart and move them around. So think first about what are the right chunks? What are the things that should be together? What are the things that should be separate? Think about data ownership and data lifecycle. One of the big shifts that is happening, in systems historically, you've had this big enterprise data vault, and the application sort of spread around this massive vault of data. And what we're moving towards is separating out that data and thinking more clearly about this particular kind of data has this life cycle. When is it created? Who can create it? How is it transformed? Who owns it? I remember one organization, we were trying to get somebody to sign off on a data migration. We had to go all the way up to the CFO of a Fortune 10 organization to find someone who had the authority to sign off on all aspects of a data migration of one system. That's how intertwined all of that data was. We had to go to the CFO of the organization. So think about data ownership, think about data lifecycle, and see what that does in terms of how you start to look at your functionality differently. Appropriate coupling. Notice I didn't say loose coupling. Loose coupling is not always what you want. It depends on what you're trying to achieve. But you want to think about what are the consequences of these things being tightly coupled? What are the consequences of these particular things being loosely coupled? And think about how that is going to impact your ability to change. Now, you might not have a choice. You might really want to separate these things because you think they're going to move around a lot, but your performance requirements say, I can't put anything in the middle there. I can't put an abstraction layer in there. That's why I use this phrase, appropriate coupling. The lightest weight tooling and documentation you can get away with. That doesn't mean no tools, that doesn't mean no documentation, that doesn't mean you won't have something that's heavyweight. The lightest weight that you can get away with. Why? Because again, the heavier something is, the more difficult it is to change. Now, what about development for evolvability? How do we think about, this is not something necessarily specific about code, but how do we think about code? And the first thing is, there are in fact metrics that you can use to measure how difficult it is to change a piece of code. And normally this comes down to how difficult is it to understand a piece of code. Because changing it always requires first understanding what's there. And so you want to focus your thinking about metrics on what does it tell me about how difficult it is for this to understand. We've done a fair amount of work. Eric Dernenberg, who also works for us, has published a couple of articles on his blog about a metric called toxicity, which is a composite metric about architectural structure, about code structure. A lot of it comes down to class size and method size, cyclomatic complexity, but it's a composite measure that allows us to assess the quality of a code base. Very often we get brought in, help me get out of this mess. And very often when you run a toxicity report over any piece of code that's been around for any length of time, it looks horrendous. Normally we like to see numbers, roughly in the 5 to 10 to 20. Sometimes we actually get arithmetic overflow computing some of these toxicity metrics. You'll see these spikes that are, 3,000, 5,000, things of that nature. And so people look at this and say, it's going to take me years just to clean this thing up. Well, what you want to do is you want to find your hotspots. And the hotspots are not just where the code is bad, but it's also where the code changes. How do you determine that? Look at your check-in log. Look at where your bug reports have gone. Go ask the people who actually use the code, when do you get nervous when you find out what pieces of functionality are changing that make you nervous that it's changing because you know things are just going to collapse in a heap? Ask your ops people the same thing. Ask the people who test the system. Where are those areas that you just, shivers run down the back of your spine when you hear that they're going to change this because you just know it's going to be ugly? Find those and cross them with that toxicity report. If something hasn't changed in 5 years, it's not in an area of the code that the business thinks it's going to change, hold your nose and ignore it. It might be smelly, it might be horrible, but if you don't ever have to change it, it's not a very good investment of your time. Maybe you'll get lucky and they'll toss the whole system out and you never have to look at it. So focus your efforts in the places that matter. And the other people you go ask is, go talk to your business people. What are the pressures are they seeing in the marketplace, which might result in you having to change something in your system? What are the areas that you need to worry about, and focus your efforts there? And the absolute number is less important than the trend. So measure it continuously over time. And I actually feel this holds for performance testing as well. You might not do anything about it, but if your metrics are going around like this and all of a sudden they go like that, it's like, okay, what just happened there? Maybe there is something inherent about the piece of functionality that you just implemented that means it's going to be messier. Maybe you got a new project manager who is cracking the whip over the team, and all of a sudden they're throwing out everything they know about how to write code because they're scared for their job. Okay, well, that's a different kind of solution to the problem. Maybe you really don't yet understand the problem well enough, and your first pass of the code was ugly, and now you can go back and look at how you might clean it up. But you watch these things over time, rather than at a point in time, okay, anything over 15 is bad and has to be changed. That's not useful. A key part of enabling any kind of evolvability is to think about how hard is it to change my mind. This concept of reversibility. If there is a decision that is really hard to step back from, actually jumping out of the airplane, it's very difficult to reverse that decision once you've done it. Okay? Other decisions are easier to step away from. How hard is it going to be to change that decision? And everything that you can do to make it easier to reverse your important decisions will increase your level of evolvability. Sometimes it might not be worth it. Some of those decisions, it makes more sense to just say, I'll pay the cost of having to reverse it, because the probability of that happening over in this piece of function that has never changed. The laws of physics don't change very often. Generally accepted accounting principles, they move a little bit, but they don't move very often. Customer expectations, yeah, those change quickly. Those are the things where I want to think very carefully on how hard is it to change my mind if I have to change my mind, and then make it as easy as possible. So, Postel's law. This particular principle talks about information exchange. And this can be any kind of information exchange, and you might not even want to think about it in terms of just exchange. how different entities look at a piece of data. And it has two parts. You want to be conservative in what you send. You want to be conservative in what you say. At one point, in information architecture and information design, people felt, okay, if I have a customer object, anybody who wants anything out of the customer object, just send the whole thing. That is a clear violation of Postel's law. You want to be conservative in what you send. And the other side of that is you want to be very liberal in what you receive. If my piece of application only cares about a zip code, I shouldn't be looking at anything else. If whoever is sending me that information changes something about the zip code, I don't have a choice. I have to do something. But if they change something about the address or the telephone number or anything like that, it shouldn't affect me. If I am liberal in what I accept, then I'm only going to have to change when there is no choice. So you only validate what you need. If you think about this in terms of schema validation, don't run everything, don't couple everything to I'm going to parse the entire XML message so I can pull out my zip code. Because anytime anybody changes anything else, you have to do something about it, and you shouldn't care. We can't make it so that every change is protected for you. Part of the be conservative in what you send is you only want to send things that you're really pretty confident you're going to continue to be able to send. So think about this when you're talking to a database, when you're designing a message validation, when you are designing any kind of communication between components. Be conservative in what you make available and be liberal in what you receive. Many systems that we see, you end up with this massive integration through the database. And you can't do anything to the database because you've got hundreds and hundreds of systems that are tied directly to the database, and they know everything about everything that's in the database, and they're all making their own assumptions. Another clear violation of Postel's law. This holds for any kind of information exchange. If you can think about the context of how am I going to communicate, and I can limit the extent to which you are making assumptions about what I am doing that you don't need to make. That's what you want to limit. And if you are in a situation where you think this information may be volatile, you might in fact decide to introduce version numbers or some kind of versioning mechanism before you actually need it. And I know this is heresy. You aren't going to need it, so you wouldn't ever think about this. But introducing a versioning mechanism into an entire system that never thought it was ever going to have to deal with versions, that's a pretty catastrophic change. So if you are in a situation where you think you're going to have a lot of volatile information, you might want to prioritize thinking about how you are going to manage things like versioning when a contract has to be broken. Okay. Architecting for testability. Again, we're test obsessed. But one of the things that we've found is the kinds of things that you think about in terms of testability tend to give you a well-architected system. What sorts of things do you think about in terms of testability? Well, how many different things do I have to test to know whether this thing works? If it's a this and a this and a this and a this and a this, that probably means you've got too much stuff going on in there. And so you probably want to separate out those things. And that's going to give you a system that has less coupling and less entanglement of things that perhaps don't need to be entangled. Do you actually have a way of independently testing these particular elements? Is there some sensible way to test them? Again, that tends to give you nice layers around individual pieces of functionality. There is something about thinking about testability that results in a well-architected system. Some things that are more concrete about this. It's very difficult to test things like stored procedures. It's very difficult to test business logic that ends up getting inserted into a messaging infrastructure. There are things that are easier to test and harder to test. This is one of the ones that we run into a lot, where people shove more and more business logic into this messaging infrastructure because, oh, of course, well, it's an enterprise service bus and it's going to solve all these wonderful problems for me. But it's difficult to test those things. And it's difficult to understand how business logic living in that layer might be impacting other parts of the system. You've got things, in fact, inappropriately distributed. To the extent possible, think about things when you're looking at what is a sensible decomposition. Don't think about it in terms of technical layers. Don't think about it in terms of what it means for you as a developer. But also think about, how does the business think about this? Because if they're the ones who are driving your requirements, they're probably going to think about their business in terms that they understand. And they are going to have ideas that are compatible with their understanding of how the business works. And if your code is organized around what makes sense technically, your solution is going to be further away from something that is easy for them to move around. So think about the focus on what does the business think about how different pieces of information are relating to each other, how different processes interact with each other, how these pieces of data flow through the business, not necessarily through the systems. That will tend to make it easier for you to move things around in a way that the business is asking you to, because they're not going to think about it in the way it's organized technically. They're going to think about it in the way it's organized in their heads about their understanding of the business. Obviously, if you're architecting and developing for testability, you're going to be doing a lot of testing. And you need to do this at many different levels. One of the most useful levels when you start to think less about code and more about systems as the whole is, how do I know that system A over there still works the way I assume it does? And so we talk about this notion of contract testing. In fact, in many organizations, one of the most valuable functions that this person called the enterprise architect can actually play within an organization is they are the keeper of that arcane knowledge of how system A and system B work together. And what are the things that if you change something in system A, you know you're going to have to change system B. We use these contract tests to start to document the assumptions that system A is making on system B. So I write these tests as a developer of system A, and I give them to system B's team. Run these in your build. When one of these breaks, we've got to talk, because you have now violated one of the assumptions I'm making about your system. Oops. There we go. And that means I now know when something a completely different group is doing, often a completely different place, I know when I have to have a conversation with them. And when we talk about agile testing, everything is always about, you want to get the information that's going to cause you to do something as close to the event in time as possible. Unit tests, you want to know when you've broken your code or someone else's code. Functional tests, you want to know as soon as those things get put through the build that this piece of functionality is broken. This is the analog to that. I want to know, and my development team over here sitting in Vancouver, I want to know when the group in London just changed something that's going to mean I have to change. This doesn't prevent those changes from having to occur, but it means that you can talk about it at the earliest possible moment, because I'm now documenting those assumptions about what those other systems can do to make my life miserable. And of course, with all this testing going on, you want to start thinking about the notion of a build pipeline. It's not just that you automate all of your tests, but you need to think about your tests in terms of, how am I refactoring them? Tests are code too. Some tests need to be thrown out. Some tests become redundant over time. So think about how you manage the different stages of your build so that you can incorporate all of these different levels of testing. And now for something completely different. Conway's law. The organizational dynamics, the organizational structure will affect the way a product is actually designed. One of the stories that Martin tells, he was talking to someone who was supposed to be developing a compiler many years ago. And they gave him this team that was in 4 locations. And the guy said, right, I'm going to have a 4-pass compiler. Regardless of whether that's what he wanted or not, he knew that's what he was going to end up with, because if you've got 4 different teams in 4 different locations, you're going to end up with a 4-pass compiler. So think about it from the perspective of how does your organization look, and what does that imply for your product? Because your systems are going to end up reflecting what your organizational structure is, which is often why it's so difficult to change organizational structures, because the systems and the organizational structure are so closely tied together. Now, what are the implications from an architecture perspective? If you have 2 groups that don't like each other, chances are that integration is going to be hard on a systems level too. Broken communication organizationally means that integration is going to be tough. And I've seen it play out so many times. You can almost predict. You spend a week talking to different people and say, okay, this is going to be a cakewalk, that's going to be murder. Because those people don't know how to talk to each other. How are you going to integrate systems if you can't even get the people to talk to each other? And silos very often result in broken communication. There was one organization that I went into, it almost felt like they had designed the organization specifically to never successfully deliver software. They had so many different silos, and no single piece of functionality could ever be rolled out without the involvement of at least 5 different development teams. Nothing. It's like, how do you ever expect to deliver software when you have all of these silos and all of these pass-throughs and all of these communication and all of this organizational distrust? I mean, it was pathological, this organization. Not surprisingly, they were rather far behind and rather over budget. So think about the realities of your organization. And then, if you don't want your product or system to look like your organization, you have one of 2 choices. You change the organization or you change the product. The compiler writer changes the product. I am going to make a 4-pass compiler. As a development team, that's probably your only option. Look at what constraints the organizational structure is going to put on your system and figure out how you can make that the least painful. Okay, so now I want to talk about some specific techniques that we use that are roughly in this area of evolutionary architecture, and try to see how does this promote evolutionary architecture. The first 2 are relatively non-controversial. Every time I give this talk, the third one is where people just, oh, what are you talking about? The first one is database refactoring. The second is continuous delivery. And the third is REST. Hypertext as the engine of application state. These are 3 very different approaches to building, or techniques that we use when we build systems, and they each have some aspect of evolutionary architecture in them. So the first, database refactoring. It's fascinating to me, having been in this agile world for longer than I care to admit. There's been this progression. First, oh, well, Agile and XP are wonderful for developers, but it won't apply to me because analysis has to be done all at the same time. Testing has to be done all at the same time. Clearly, I still have to have an overall 3-year project plan. Database design, you can't start developing without the full database design. Architecture, experience design is the latest place where we're seeing this. Well, all this Agile stuff is wonderful, but first, let me do my big upfront experience design so I know what the customer engagement will look, because that can't be split up. Database was a particularly challenging one. because there is often this disconnect anyway. You've got the specialized database team, which is, you know, the keeper of this enterprise vault of data. So there's already that, you know, broken communication going on there. But there is the book on refactoring databases. And this is how this takes you through how you can take an existing database and change it in an evolutionary fashion, in a way that's safe, in a way that works well within an agile development process. And the key thing here is that every single database change that you make, you decompose it into a series of very small refactorings. And that's where this phrase, just like when you're going to overhaul this entire piece of code, you're doing these small refactorings and you're composing them together to implement this entire change. Rather than spending the 3 weeks to change everything and then doing the big check-in, you're incrementally refactoring your code, making one small change at a time, and then the next, and then the next, which is what the term refactoring is supposed to mean, rather than the radical surgery that it ends up often being used as. So for each change in the database, you have either a pair or potentially a triple, depending how you think of it. What are the things that you have to think about when you make a change? Well, you actually have to change the database. Whether you're changing a name, you're adding a column, whatever you're doing. What is that change that you're actually making to the structure? That's component one. Component two is, how do I migrate any existing data I have to respect that change? What do I have to do to bring the data in line with this new database structure? And that's the pair. And then, of course, the third, if you want to think about it that way, is what are the code changes that I have to make to deal with the data in a new way? Any database change, you've got to think about all three of those things. Now, what the DBAs will tell you is, you need to decide all those things up front because you can't do data migrations. Well, data migration is hard. By decomposing the data migrations, you make them easier. It is still going to be hard to migrate data that is 25 years old, that has never been cleansed, and hasn't really been validated, and all of those things. I'm not saying that this is a silver bullet, but we do at least have a way of breaking a massive database change and a massive database migration into a series of much smaller ones where it's easier to verify that the migration worked, and it's easier to find those pieces of data that have been sitting around since the dawn of time and nobody's ever really done anything with. And just like when you compose refactorings, or just like when you compose functions, you compose these individual single database refactorings into the larger one. And of course, version control the changes. Fortunately, in this group, you know, things like the use of source control are probably not radical concepts. But you can version control these things, and that way you can also know, okay, these are all of the migrations that I have to run when I promote from this integration test environment to a user acceptance environment. These are the scripts, because these things are not just conceptually composed, you put them in scripts. And you run those migrations as you promote the code, which also means you've got a way of testing that migration before you're actually migrating your production code. Which is that. So, what does this look at in terms of evolutionary architecture? Well, what we're saying here is these are techniques that you can use to convince the database group, no, I do not need to have the entire full database design before I start writing my sandwich ordering system. I promise you that I can migrate my sandwich orders if I have to. So this is something that allows the incremental development of a data model, which means that all of those things that you wanted to decide about, well, you know, which should really be, you know, the owner of this relation, or any of those things, you don't have to decide them right away because you have a chance to even make relatively radical surgery. Just like a good unit test suite allows you to make pretty radical code surgery, using this approach can allow you to make pretty radical changes to your data model and still safely migrate your data. And as an aside, there's nothing about this approach that only applies in the relational world. Migrations, when you're thinking about a graph database or a document database or a column store, the same conceptual problem applies. I still need to know what change I'm going to make to my data. I still need to change how it is I access that data to access it in the new way, and I still need to think about migration. What those specifics are very different. What the patterns of migrations are clearly going to be very different. And in fact, they're very different between a graph database and a column database. But this same way of thinking about data migrations applies just as well in the NoSQL world. Second technique, continuous delivery. The goal of continuous delivery is to make it as easy as possible to get things through to production. And anybody who's put a system into production, we know where these things go wrong. Well, the production system isn't on the same version as the test system is. Or this configuration is a little different. Or this environment is a little different. And so the first thing is you're going to automate practically everything involved in your process, including how you provision environments. You don't want a work of art, this finely tuned machine that is different from every other machine, unless you have no other choice. To the extent possible, you want provisioning of environments to be automated. You want to know that when I spin up a test environment, it's going to look the same way it did yesterday. You're going to automate your builds and your deployments, not just your builds. We understand the value that we get from continuous integration, and you're not going to continuously integrate if you've got to manually run the build, but the same holds true for deployments. And we need to think about this not just in the context of sticking the system out into production, but how do we configure things? Many of the tools that are out there actually make it very difficult to automate a deployment. They assume you are going to have an operator sitting there typing onto a wonderful, pretty GUI. Those things are often very hard to automate, but to the extent possible, you want that deployment to be completely automated as well, because scripts tend to make far fewer mistakes than some poor operator sitting at 3 o'clock in the morning trying to actually type everything right. Doesn't matter how good the instructions are. Automate your testing at all levels. Performance testing, smoke testing, all of those different things should be as automated as possible, because anytime you have a manual testing step, it takes longer. The objective is for deployments to be boring. How often is the celebration not, look at all the wonderful new features that we just delivered to our users, but it's, thank you, that's done, nobody yelled at me, the system was only down for 4 hours, isn't that wonderful? You don't want to be celebrating the fact that nothing went wrong. You want to be celebrating the value that you're delivering. You want this to be boring. Deployments should not be exciting. They should be exciting for what you're delivering, not the fact that it didn't fall down in a heap. And this is an important point too, because it's fascinating. The minute we start talking about continuous delivery, people get all panicked. Oh, you mean some developer is going to check something in and then with no controls whatsoever, it's all of a sudden going to be in production? Well, yes, that's possible, but it doesn't have to be that way. Just because you can deliver everything quickly to production doesn't mean you have to. Go back to what Diana was saying earlier. What is the cadence that your user community wants? But wouldn't it be nice if something did go horribly not the way you expected, to be able to very quickly roll out a new release with very little risk? Wouldn't that be nice, just in case? So just because you can doesn't mean you have to. But what you want is for the business to be able to determine when something is going to go live, not IT. IT should be able to respond to what it is that the business needs, and then they can decide. There's nothing at all. If you read the continuous delivery book, if you listen to all of this, there's nothing that says there can't be a manual approval step, that maybe the auditors have to sign off, or maybe you know, the CEO of the company wants to have that final say-so on before something goes out. There's nothing about that that says you can't do that. You do not have to deploy into production every hour just because you could. And it's amazing the number of people who seem to think that one implies the other. Okay, so now the more controversial one. Hypermedia as an engine, hopefully it's obvious why continuous delivery enables evolutionary architecture. Probably shouldn't have to go through that too much. So Hypermedia is the engine of application state. Now, one of the times I gave this talk, it's like, why on earth are you preaching rest to me? You know, this has nothing to do with evolutionary architecture. I'm not saying that this is how everybody should always design every possible system. I'm using this as an example to show there are some architectural approaches that in certain circumstances will make it easier for you to move things around. And this is one of them. How many of you are familiar with REST in here? Okay, so I don't have to go through too much. One of the interesting things about REST is the way information ends up getting distributed and how different that information distribution is from how it is in systems that are architected in different ways, in more traditional ways. Because what you are effectively doing is what you are passing, what is flowing is not processing so much as this conglomeration of state and knowing what you can do from this particular point. So you are breaking, if you will, you are looking at the flow of information, the flow of processing, and where those change points can be inserted, and you're turning that around, which gives you options for making changes that are different than a more traditional architectural approach. So you're distributing this information differently. Now, one of the interesting things about thinking of the REST architectural thinking style, you begin to think less about how I'm going to give something to others to use, and you start to think more about how somebody's going to pull something. Your interfaces become less, as the enterprise IT department, this is the customer information I'm going to make available, to I'm the customer service department and this is the customer information I want from you. So you're flipping who it is that's really controlling the interaction, who it is that's deciding what this interface should be about. And you think about this from the perspective not of how I want to process the data, but how does the user want to use the data next? And it turns that conversation around, which means you end up looking at your flow of information differently. You end up having different avenues for changing that interaction, for adding new possibilities. Because you were looking at this from the perspective of who's consuming. Now, REST done well is also, you begin to deal much more directly with how contracts have to evolve, how these changes can be taken into account. By thinking about how that flow differs, by focusing not so much on what I want to give, but what somebody wants to get, you almost inherently begin to think more about how is this thing going to change. Because change is not, we don't even think anymore about change being something that we control. When the design perspective is, I'm going to give you things, I decide what I'm going to give you. I decide when I'm going to change what I'm going to give you. When you shift that perspective around and it's now the consumer is driving this, the person is asking you for what they want, you don't have control over that anymore. So you have to start thinking far earlier in your process, how am I going to allow these things to evolve? Because I'm no longer able to exert the same kind of design authority over the changes that I could before. So you start to think about how am I going to evolve these information exchanges earlier than I would have in traditional systems. And of course, there are all kinds of properties of REST that I'm not going to get into, but they also give you additional options. Item potency, for example, the fact that I can redo things and that's okay. It gives me options for how I might handle things like failover or dealing with error handling, those things. I have options that are much more difficult to take advantage of if my system is implemented differently. So this is not to say everything has to be REST, but there are aspects of thinking about a system from this hypermedia perspective that you are faced with different choices. Some things are easier, some things are harder. Okay, so laid out some principles about how you would think about architecture in a way that will make it easier for it to evolve, and the implications that has on your design process. Talked about a couple of very specific techniques that highlight different aspects of what would allow an architecture to evolve. So how do you actually do this? First and foremost, you do have to think about what is your architectural fitness function. What are the things that are important in your system? In the sandwich ordering system, it's probably the happiness of the users. In the trading system I was telling you about, fundamentally it was I cannot lose any data. Full stop. Other systems, it's going to be performance. It's going to be failover. Whatever those things are, go through your list of abilities and decide which ones are the ones that are important. Define that fitness function. And then every time you were faced with okay, do I decide this yet? I can decide when to take that decision. I can also continue to monitor how my architecture is evolving to ensure that I'm respecting my fitness function, that I'm not making some choice that takes me further away from what my actual architectural requirements are. This is a much lighter weight architectural control mechanism than some of the traditional control mechanisms that organizations try to put in place. So delay your decisions as long as you can, respecting your fitness function. Understand and manage the various forms of technical debt. Just like debt is not a bad thing in and of itself, you want to manage it. You might, in fact, choose to make a decision that incurs technical debt, and there's absolutely nothing wrong with that. You don't want to incur it accidentally, and you don't want to incur it and not do anything about it. But, so, understand it and manage it. Implement evidence-based reuse. One of the more frustrating conversations I often get into with some people in our architecture groups, and fortunately this is becoming less prevalent, but it's still there. IT managers still have this holy grail that somehow magically, if my architecture group is good enough, I'll have these suites of reusable components and I won't ever actually have to write any more new code. I can just, reuse all of the stuff that's floating around my enterprise somewhere. And reuse is really hard. And very often we also get brought in, I would like to build a framework to do this. Said, well, do you have any example systems that might reflect the framework? Oh, well, no, I want to build the framework first and then I'll build the instances. Well, how do you know what knobs you're going to want to turn if you don't know what the instances look like? Part of the power of Rails is it came from the fact that they built a couple things and said, there's some commonality here. I'm going to pull out that commonality. I'm going to extract my framework. Evidence-based reuse. I have evidence that this is how these things are used. These are the things that are common. This is where I have to specialize. This is where I have no clue what it's going to look like, so I have to be very flexible there. Make it evidence-based. Some poor person sitting in a room somewhere is never going to be able to dream up all of the different ways that somebody is going to want to use customer information. And unfortunately, what they will probably do is they will dream up all kinds of ways people might use customer information and spend all that time writing all of that stuff. One of the beauties of Agile is all the code that never gets written, because people no longer continue to ask for things because you're only going to ask them once every 2 years what they want. So they're going to have to think of all the things they might possibly want. This is the same kind of problem. Implement reuse on the basis of facts, of evidence that we know we can reuse this, rather than trying to speculate. And then create and maintain your testing safety net. Yes, we are test obsessed, I'm sorry. But without a testing safety net at all those levels, have you tested your deployments? Do you have a smoke test? Without those kinds of things, all of the change that we're talking about here is simply too risky. Agile isn't a license to be irresponsible. All of this, we don't have to plan ahead, we don't have to do this, we don't have to do that. The practices and things like this testing safety net are what decrease the risk associated with Agile. And that is evolutionary architecture.